friends, in this lecture I would like to explain another example based on the two-hinged arches. That is, a two-hinged parabolic arch of span L and a rise R carries a concentrated load W at the crown. Determine the expression for horizontal thrust developed at the springings. See here, this is the two-hinged, one at A, another at B. Only hinges at the springing levels. So here they are asking at the springing. Springing means abutments both at A and B, and crown, that is point C, which is exactly at the center. So for three hinged means, so there will be one more hinge at crown C, but here only two hinges, one at A, another one will be B. That is the difference between two hinge arches and three hinge arches. And at the same time, what they are given? So a two hinge arch consists of, this is rise, R is rise which is given, and a span of L, and at the same time concentrated load W exactly at the crown. See here, what are the reactions? So this is the load which is acting exactly at the center. So we know one condition, whenever on a simply supported beam, if a point load is acting exactly at the center, the reactions will be distributed equally. Here also, due to symmetrical conditions, your reaction at A will be equal to, Ra will be equal to W by 2. Similarly, reaction at B will be equal to W by 2. So this is the span of length L. So what is the exactly here from taken from here to here? So exactly half of the distance from here to here, L by 2. Similarly, L by 2 to here. So this is also from here to here. Okay. Then, so determine the expression for horizontal thrust. So what is the formula for the horizontal thrust on two hinged arches? So that is simplified in the last lecture. Please go and check once what is the formula. That one will be equal to m dash y dx by a integral of y square dx by a. EIA will be same. So that is new constant here. And what about this m dash? M dash will be the beam moment for at any point x comma y, and y is the point where we have taken. For example, here we are taking suppose one some point p x comma y, means for example here we have to consider one section xx, we have to consider the section xx at some distance in both x direction. So here we have to consider this section from here, it is at a distance of x axis. So we have to consider section xx at a distance of x from point A. So for example, this height will be y here, and the distance here will be x. So this y equal to that particular height of that point x comma y. Then what is the formula? So already we solved so many problems for that one based on the three hinged arches. So your y, whenever parabolic arches will be given, your y will be equal to 4r by L square x into L minus x. So this is only for the parabolic arches. So this r is the central rise. So whenever we have to find intermediate height of that particular curve means, your y will be taken equal to this formula, and that too only for the parabolic arches. Okay, whether it will be two hinged or three hinged, you can remember this formula directly. And what about this m dash? M dash is the beam moment. So this is the formula for finding horizontal thrust. First you can find out the numerator part. So what is numerator here? That one will be equal to m dash y into dx. Okay, first what is y? Y 4r by L square x into L minus x. Then what about m dash? So m dash will be equal to, that is B moment. So resolve this force up to that particular section, W by 2 into x, force into distance. So W by 2 into x. So that is W by 2 into x. Then y equal to 4r by L square x into L minus x. So I will simplify this numerator part, that is integral of w by 2 into x, and again this y dash will be equal to 4r by l square x into l minus x. Okay, so that is the numerator part. And again, one more thing what we have to remember here means, so already I told you this point in the last lectures also, that is, so 0 to l f of x dx, whenever if the function will be even, that will be taken due to symmetrical condition, that is 0 to l by 2, 2 times of f of x into dx. For example, in terms of pi, 0 to pi f of x dx will be equal to 0 to pi by 2 into 2 times of f of x dx. So the limits will be distributed 2 times. Why? Because due to symmetric condition. For example, we have to simplify the same problem. Either from right side we have to consider this section at a distance of xx from b also. But we are simplifying only in the part AC. The same problem you can simplify in part CB also. But we are simplifying only in one part. So the same movements we can apply in the entire arch, that is L part. Therefore, whenever symmetrical conditions happens, you can take down the formula like this. So if f of x will be even, it will be 2 times of 0 to L by 2 f of x dx. So your limits will be taken equal to overall span length, that is 2 times of 0 to L by 2 w by, so this 2 and 2 will be, so w by L square 2 w r x square into L minus x. Again simplify this one, 2 to 4, I am sending this one outside, and again w r by L square integral of 0 to L by 2. Simplify this one, Lx square minus x cube. So each and everywhere dx will be there. Here also dx, integral of m dash y dx, dx, dx for whole. Next, so apply this integration with respect to dx. So 4 wr by L square, then here L will be okay, taking same common, integration of x square with respect to dx, that is x to the power of n will be equal to n plus 1 by n plus x to the power of n plus 1 by n plus 1, means x cube by 2 plus 1 by 2 plus 1, 3 plus 1, which is 2 plus 1, 3. So integration of x to the power of n will be equal to x to the power of n plus 1 by n plus 1 minus x cube will be equal to x power 4 by 4 in the same way. We know the formula, that one. And again we have to apply the upper limit to the lower limit. Then 4 wr by L square, apply the upper limit, L into x cube is L by 3, x cube is L by 2 whole cube, minus 1 by 4 x power 4, which is L by 2 power 4. Then again simplify this one. So simplification will be same. So already we know the mathematics. That is L power 4 by 2 3 times, 2 to the 4, 4 to the 8, 8 to the 24, minus L power 4 by, so here 2 to the 4, 4 4 the 16, 16 4 the 64, and again wherever the terms common you can take down outside, 4 wr L power 4 by L square. Simplify again this one, 1 by 24. So you can use your calculators directly. So for semester examination, calculus will be allowed. So square and powers 4 will be cancelled. That is 4 wr L square. And you can simplify entire this part directly by using your calculators. So finally, how much it will be obtained? You check once. So this is 4r L square 1 minus 24 by 1 by 64. So simplify this one directly. So your numerator part will be equal to around 5 by 48 W or L square. So you can simplify, you can maybe you will get in terms of decimals also, some 0.19, like around whatever the value, you can take down the value whatever obtained directly the calci. So this is the numerator part, which is m dash y dx will be equal to this much. And again next to solve the denominator part. So what is denominator part? We know that one, integration of y square dx. So what is y square? Entire this value. Again simplify step by step. We will see what it will be. So denominator will be equal to integration of y square dx. That one will be equal to integration of 4r by L square x into L minus x, that is whole square dx. Here also you can take down 2 times of 0 to L by 2. For knowing this property in the max, already I simplified one problem, that is second two hinged arches, second example, one after the introduction clearly. So I will also give the link in the description. You please watch that video. You will get the clear idea how I will take this property directly. Okay. So this one will be 2 into 0 to L by 2, 4 square, that is 16 r square by L power 4 into x square, and again L minus x whole square. So simplify how much possible. Otherwise, you can take down directly in the calculators also. Directly, you will get this one, 13 r square by L power 4 integration of 0 to L by 2 x square L square. It is the form of a minus b whole square. L square plus x square 2lx minus 2ab into dx. And again simplify this one step by step. First simplify and then only you can apply the integration. X square L square plus x power 4 minus 2l x cube dx. Then again simplify this one, 32 r square by L power 4. So apply the integration with respect to x, that is here L square into x cube by 3. I am applying integration for the x cube by 3 plus for this one x power 4 means x power 5 by 5, and again for this one minus 2l constant, and then x cube means x power 4 by 4. So you have to apply integration, that is 0 to L by 2. So this is L by 2 here. Take down L by 2, not L by 4. So upper limit minus lower limit. So for lower limit, all the terms will be 0 only. You will get all the terms 0. And what about the upper limit? I will apply here. Check once. So that is L square by 5. X cube means L by 2 whole cube. I am applying upper limit. So lower limit is 0. And again 1 by 5. X power 5 means L by 2 whole power 5 minus 2L by 4 into x power 4 means L by 2 whole power 4. And again simplify, 32 r square by L power 4. So L square L cube is L power 5. So 2 times of 3, 2 to the 4, 4 to the 8. 8 into 5. So how much you will get? You will get around. So see here, this is 3, not 5. So this is L square by 3. I am taking outside. Okay. So 2 to the 4, 4 to the 8, 8 is the 24. Plus 1 by 5 outside. So 2 to the 4, 5 twos like this. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. 32 into 5. So 32 into, so it is around 160. So 160 into L to the power of 5 minus 2 and this 2 cancel, and again L power 4. So L into L power 4, that is L power 5. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. So this is the simplification, and again remove the common terms outside. 32 r square L power 4 into L power 5, and again 1 by 24 plus 1 by 160 minus 1 by 32. So these terms and these terms cancel. How much you will get? 32 r square L into entire this value. So take down LCM common and you can do. Otherwise you can take down all the values directly by using your calculator. So it will be around how much? So for me it will be 8 by 15. I am taking the value directly after simplification, that is r square L. So 8 by 15 r square L. So if you want you can take down decimal fractions also. So this is integration of y square dx value. So this is the denominator part. So we know the horizontal formula will be, horizontal thrust will be m dash y dx by integration of y square dx. So what about your numerator and denominator? Your numerator will be 5 by 48 w r l square. Denominator part will be 8 by 15 r square l. So if you simplify again 5 by 48 into WRL square into 15 by 8 R square L, like that you will get. If you simplify it will be around 25 by 128 WL by R. So maybe you will get in terms of decimal fractions also. 25 by 128 will be equal to how much? The times of WL by R. So finally your horizontal thrust will be equal to, the value will be 25 by 120 WL by R. So you can take down in terms of fractions, or else you can, if you want, you can take down in terms of decimals also. Okay. So this is the horizontal thrust for the point load exactly acting at the center. That is 25 by 180 128 WL by R. 25 by 128 WL by R. So your horizontal thrust, that is H at A and B, will be equal to 25 by 128 WL by R. So this is the horizontal thrust for the given topic.
Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.